In this video, you'll learn how Hackolade helps modernize applications when migrating from relational databases to MongoDB Atlas by optimizing schema design to best leverage the power of MongoDB and its document model. The dynamic schema evolution in MongoDB provides new power and flexibility with the storage of data in a JSON document format instead of in relational tables. Accolade has been pioneering data modeling for NoSQL in general, and MongoDB in particular, so companies could modernize applications while also ensuring proper data management and governance. Accolade was built from the ground up specifically to handle embedded structures and schema evolution of JSON documents in MongoDB. This is done by extending visual entity relationship diagrams capabilities to accommodate the representation of JSON hierarchical structures with nested objects and arrays. With our Hackolade Studio tool for schema design, we embrace agile development with several use cases, including forward and reverse engineering, data governance, design-first model-driven API generation, etc. One of the use cases for the tool is demonstrated next to illustrate a typical migration exercise. 1. We will reverse engineer the structure of a relational database using one of the popular dialects of SQL. 2. We will optimize the data model through denormalization, making sure to analyze access patterns of the application and design the schema in a query-driven approach. 3. We will produce several artifacts for the different stakeholders of the application. The demo will illustrate the benefits of the joint solution put together by MongoDB and Hackolade to increase quality, lower risks, and lower total cost of ownership. Now for the demo of a migration from RDBMS to Atlas. Let's create a brand new empty model for MongoDB and import a data definition language file from one of the different SQL dialects, in this case Oracle, for the famous Northwind database. After a little bit of visual rearranging, we now have a traditional data model diagram relational with flat tables. This is the model that we migrate to MongoDB Atlas, but it is best to make the schema evolve to utilize the strengths of MongoDB. This is done through an exercise of denormalization to combine multiple tables into one so as to improve access speed to the information stored in Atlas. First, we want to embed order lines into the orders collection so as to eliminate an outer join and store together information that belongs together and improve speed. We invoke tools, suggest denormalization, and select the two collections concerned. Here, we're interested in embedding an array of order lines into the parent order table. After the operation is performed, we can now delete the order details collection and see how easy it was to denormalize the schema. Then, we want to embed some of the product information in the order lines, as it would make sense to further reduce the need for an outer join and store product name and unit price in the order line. We first create a foreign key relationship, but this time we're interested in embedding a subdocument into the child collection. We're interested in retaining the master collection of products because there is a separate use case to maintain product information. After the operation is performed, we can delete the unnecessary fields and keep just the desired ones. You may wonder why all of this is not completely automated. That's because denormalization should be a function of how data is being accessed to maximize performance when reading data. This is where the data modeler's expertise and experience come into play with the assistance of Accolade. When you're done with denormalization and have saved a first version of your model, you may engage in a conversation with the different stakeholders of the application. With business users, using documentation in HTML, Markdown, or PDF formats. With developers, using scripts in console syntax, JavaScript, or Mongoose schema. With DBAs, using diagrams and index specifications. Or you can generate the documentation for a model-driven Swagger or OpenAPI to discuss with customers and API consumers. Another useful exercise is to commit sample documents to MongoDB Atlas, then retrieve the estimated size requirements for each collection and their indexes. This can be exported to Excel or Google Sheets, then multiplied by estimated number of documents per collection to generate a full sizing estimate for the database on Atlas. We conclude this demo here, hoping that you will see all the benefits of the joint solution put together by MongoDB and Hackolade for the different stakeholders concerned by migration of applications from relational to MongoDB Atlas. Please consult Hackolade.com for additional information and download a 14-day free trial of the software. Thank you for your attention.